Okay, good. So the recording is in progress. Good. So I'm very happy and very pleased to introduce our speaker tonight, Chris Field. Chris is currently the director of the Woods Institute at Stanford for the study of the environment. He's also a professor for the environment, interdisciplinary studies. He's been at Stanford for many years, and he's worked on the problems of global warming and climate change forever and ever. He's touched upon every subject that you can imagine. And as a matter of fact, some of you may remember that Chris spoke to our club when we were meeting in person at the Methodist Church in Redwood City on Woodside Road. And I think that was about shortly after the Paris Agreement was signed, but I'm not sure exactly when it was. And at that time already, he impressed me a lot because he and his co-speaker was a lady who now moved to Florida, I believe. They both came to the meeting on their bicycles all the way from Stanford at night. So they were practicing what they were preaching already at that time. And Chris has done a lot of things, not just at Stanford. He was the co-chair of Working Group 2 for about 7 years with the IPCC. And he wrote several reports when he was there. And he belongs to a whole bunch of honorary societies. He's a member of the American Academy of Sciences and many other places. And I don't want to take any more time because he will talk to us about the urgency of the problem, which when he spoke, I remember 5 or 6 years ago, was already a very important subject. But I remember that at the time he said, we asked him whether we could solve the problem, and he said, I think so if we start acting now. But of course, many years went by, and then Trump left the Paris Agreement. So today the problem has become much more urgent, and Chris is going to tell us what we can do at this point. Thank you very much, Chris. You have the next word.
Well, thank you, Greg, and it's wonderful to see a number of old friends in, I guess you call it the audience tonight. And what I want to do is really talk about the fundamental issue of what the set of climate change solutions looks like in an era when we're fundamentally out of time. And you can think of out of time in terms of impacts like the Dixie Fire, but lots of other ways as well. I'm going to start with a statement from the latest report from the Intergovernmental Panel on Climate Change that's released in August from it's called the 6th assessment cycle. And the statement, very clear, is unequivocal that human influence has warmed the atmosphere, ocean, and land. Widespread and rapid changes in the atmosphere, ocean, cryosphere, and biosphere have occurred. The statement is actually quite similar to things you would have seen in previous IPCC reports. But what's interesting is that the language about statistics has all been removed. There's no mention of confidence or likelihood or any conditional terms. The climate change is real, and it's something that's with us. Before I start talking about what the solution set looks like, I spend just a minute talking about whether this is because our understanding of the process has really changed or what. And you know, there has been a lot of speculation about the scientific community wasn't clear on how much climate change we would experience by now. But that's actually incorrect. I want to show you what the IPCC was projecting as the most likely trajectory for climate in 1990 on the left-hand side, 31 years ago, and in 2001, 20 years ago, on the right-hand side. The observations, or the squiggly color lines, confirming the warming that's occurred, confirming that every group that tries to reconstruct the temperatures from all the thermometers around the world gets pretty much exactly the same thing. And so the projection of the IPCC made in 1990 on the left is a solid black line. Everything after 1990 is forecast, and everything before 1990 is hindcast. And you can see that without getting the annual wiggles, which are mainly a consequence of the El Nino Southern Oscillation Cycle, the projections were pretty darn good 31 years ago. In 2001, the story is pretty much the same. The transition from hindcast to forecast in this image occurs in the year 2000. And what you see is that the actual line runs pretty much through that. Thank you for the muting help. The observations are pretty much on top of the forecast. The take-home message here is that we have had a really accurate projection of where we were headed for at least the last 30 years. And we've had plenty of time to make the kind of changes that would prevent us from being on the trajectory that we're on, but we haven't done it. And so now, where are we and what can we do about it? I want to talk for 1 minute about why the focus on 1.5. Those of you who've been followers of Action on Climate know that for many years, the goal of the climate community was to limit warming to less than 2 degrees Celsius. And in fact, the explicit goal of the Paris Agreement is to limit warming to well under 2 degrees Celsius above pre-industrial, with efforts to pursue 1.5. And where did this 1.5 come from? It's been part of the dialogue within the UN Framework Convention for many years. It was primarily a concern of the small island nations, legitimately concerned about sea level rise. And in the Paris Agreement, it basically got in as part of the negotiations concerning whether there would be an explicit treatment of loss and damage, financial compensation for damage, or a more ambitious target. And the more ambitious target got in there. We talk about whether that made sense or not. The way to think about the evidence about whether 1.5 is the right target is clearest in the report of Working Group 2 of the IPCC, or this is from the Special Report on Warming to 1.5C. And it basically takes all the impacts of climate change and it categorizes them into 5 big buckets. Unique and threatened systems, things like species that could go extinct, or heritage sites, extreme weather events like we are seeing around the world all the time, distribution of impacts, whether the poor are being impacted, not the rich, global aggregate impacts, whether we're seeing changes in the total availability of food or fresh water or financial activity, large-scale singular events like commitment to large amounts of sea level rise, or a commitment to larger releases of greenhouse gases from the Earth system. And on this scale, we go from white, no observed impact, to yellow, moderate risk, red, high risk, and purple, very high risk at different temperatures. And what you can see is that especially in the unique and threatened systems, we transition into the red category at temperatures a little below 1.5 and into the purple by 2. With most of the other categories, what we're seeing is a transition from yellow moderate risk to high risk in the 1.5 to 2 region. Most of the concern about stabilizing warming to 1.5 is the risk of crossing a huge tipping point from which there's no recovery. And I want to talk a little bit about where that comes from. If you look at more of the detailed information, you can see that the risk of transitioning into very high risk is especially profound for warm water corals and the Arctic, with a high level of confidence that we hit the highest level of risk at temperatures somewhere in the neighborhood of 1.5 to 2. The take-home message that I want to leave you with is that we don't have a high confidence that any of these tipping points have been crossed yet. We don't have a high level of confidence that they're between 1.5 and 2, but we have a high level of confidence that they're real and that they would be crossed if we move out of what you might consider the world of ambitious mitigation. And exactly where that threshold is a little bit hard to say. The other thing that is profoundly important about the way we think about what the threshold should be is the link between overall warming in the climate system and the number of extreme events that we encounter. And there's no question that we're seeing more and more climate-related extreme events. In the U.S. last year, there were 22 climate-related extremes with damages greater than $1 billion. So there's no question that those are accumulating. I will argue that the extreme events are the indicators that the climate's changing, but in terms of the long-term future of the planet, they're less profoundly important than these tipping points. And there are two in particular that are of great concern. One is something called marine ice sheet instability, and it's something that could commit us to a large amount of sea level rise over many centuries, something on the order of 5 to 15 meters, 20 to 50 feet of sea level rise, a totally existential risk for the world's coastal regions and for dozens of small island nations. And the really challenging feature of marine ice sheet instability is that once the ice sheet starts to collapse, even if we cooled the climate again, it wouldn't stop it. We transition into a geophysically driven mechanism that's causing the ice sheet to collapse. A second risk that's really important is the risk of large amounts of permafrost thaw releasing greenhouse gases, some combination of CO2 and methane to the atmosphere. Again, this is a profoundly important tipping point because even if we bring anthropogenic emissions of greenhouse gases down to zero, if we've triggered a large-scale release from frozen soils, which we know contain more frozen carbon than has been emitted to the atmosphere by human actions since the beginning of the Industrial Revolution, there's no stopping it. Even cooling the planet, well, there's nothing we can do to cool because the warming is going to come from the permafrost release. So the theme that I want to speak with you today is whether we can achieve stabilization at less than 1.5 or in this region that we'll call the region of ambitious mitigation with decarbonization only or with some combination of techniques. The IPCC, in its most recent report, concluded that there are pathways that could stabilize warming at less than 1.5 above pre-industrial, but it's really, really difficult and gets to be more difficult with every year that we don't see emissions start to fall. It would require emissions to fall to zero globally by around 2050. And I want to argue that in many ways, I think the environmental justice aspects of climate change have not really been framed in the most useful way. Certainly, it's true that the most profound consequences of climate change impact the poor, but it's also true that energy poverty impacts the poor. And when we look at trajectories for global decarbonization, it's really important to recognize that poor countries especially may not have alternatives to fossil fuel use for a significant period into the future, I think 1 to 2 generations, as the technological basis for a transition to clean energy really matures. Of course, it's also true that rich countries have made limited progress. And I think the evidence is pretty clear that even less than or equal to 2C will be very difficult with decarbonization only. And one of the things we ought to be thinking about is whether there are additional strategies that ought to be deployed. So one of the reasons that this is such a challenging problem is that the amount of warming in the system is really a result of cumulative emissions since the start of the anthropogenic emissions era. This is a plot of the total amount of warming that occurs on the y-axis and the total amount fossil carbon that's been released from combustion of fossil fuels since basically the beginning of the Industrial Revolution. What you see is that the relationship is essentially linear. And if every ton of CO2 that we release to the atmosphere increases the stabilization temperature, and that increase is essentially permanent as a result of the way CO2 warming works. Even if we dropped emissions to zero tomorrow, we'd see the temperature that has been caused by the total emissions to stay in place for at least a few thousand years and probably more than 10,000 years. As a consequence of this linear relationship between the total amount of greenhouse gases that have been released and the equilibrium temperature, you can identify the point at which we cross the threshold of warming more than 1.5, and in rough terms, we have a 66% probability of keeping warming less than 1.5 C with emissions that are around 2,800 billion tons total since the start of the Industrial Revolution. Let me just explain exactly where we are with that then. So emissions to date, well, the forever budget is around 2,800 billion tons if we want to keep warming at less than 1.5 C, or at least with a 2/3 probability. And emissions to date have been around 2,400 billion tons. The area in pink on this plot is the amount that we have left. And that remaining budget is about 400 billion tons. It sounds like a really big number, but the emissions rate in 2020 was 41 billion tons. So if we were to continue at that rate, it's a simple calculation to estimate that we have a little less than 10 years of budget left for maintaining the temperature at less than 1.5 C above pre-industrial. That's a really, really short time frame, and what I want to talk about in the next couple of slides is how to understand how short that is. At least for me, it's Secretary General Guterres' comment that it's a flashing red light for humanity is certainly true. Another way to get a feel for the dramatic nature of the change that's required is to look at the historical trajectory of greenhouse gas emissions from the start of the Industrial Revolution to the present. You can see how much of the emissions has really occurred since 1950, almost all of it when you look at it on this scale. And then we can say, well, given the budget that we can calculate for stabilizing less than 2 or stabilizing less than 1.5, what does that look like in the context of this trajectory of historical increase? So if we wanted to limit warming to less than 2 C with a 66% probability, the decarbonization trajectory would in principle look something like this, or this represents the amount of allocatable budget. And we'd have to transition from an era of rapidly increasing emissions to rapidly decreasing, hitting zero in the latter decades of the 21st century. The amount of headroom remaining for 1.5 is shockingly small. We're really right on top of warming to 1.5 already. And if you allocate the total budget remaining for 1.5, you get this tiny triangle, which implies a almost immediate transition, and transition that should have occurred in the past, from rapidly increasing emissions to incredibly rapidly decreasing. That's a trajectory that, well, we know is not the one we're on. We've already seen emissions past 2019 not being on this, and I think it's very unlikely that we can get there. So I'm talking about what the implications of that are. Where we were at the end of 2020 is that temperatures were up. 2020 was the second highest year in the instrumental record. it's about 1.1 C, warmer than the pre-industrial numbers, but we really are just a hair's breadth away from 1.5. One good El Nino could certainly give us a single year with a global average temperature over 1.5 C over land and oceans, and we've already seen global average temperatures over land that were as high as 1.5 C over pre-industrial. In 2020, emissions were down by about 7%, and you might read that as good news, but it really is a reflection of the way the pandemic influenced industrial activity, and the frustrating feature of this emissions drop is what it basically demonstrates is that we've made very little progress in separating emissions from economic activity. Economic activity goes down, emissions go down. And what we need to do is find a way to have economic activity go up while emissions go down. The final thing that's important to note about 2020 is the impacts of climate change are really stark. And I'm not going to talk about impacts because everybody appreciates how strong the link is between warming that's already occurred and the impacts we're seeing. What I'm going to focus on is that there are a wide range of opportunities for delivering solutions, and they include things like energy storage. This is Stanford's energy storage facility, which is used to heat and cool buildings. It cut Stanford's energy use by 67% when it was initiated in 2015. A lot of land-based interventions that we know can help not only decrease the risk of extreme events, but also increase carbon storage. And there's some very positive and some not so positive things that are happening on the international political scene. And of course, there's a lot riding on what happens in Glasgow at the next conference of the parties at the first of next month. The thing that provides a little bit of either wiggle room or thinly veiled excuses is there's been a lot of discussion in the last several years about negative emissions, and the idea is that we don't need to have emissions drop to zero simply by having them drop to zero following a trajectory like this one. We could also imagine a situation in which emissions stay high for some period and drop more gradually and then go into negative territory later on. And this negative territory could be as a result of natural climate solutions, growing forests, improving agricultural soils, or it could be as a result of industrial processes that capture carbon dioxide from the air and remove it. The overall implication of these is that, we can have some scenarios that require just decarbonization and some that allow continued emissions for some decades before we commit to a process of decarbonization and then high levels of negative emissions. Mike Hume recently wrote a really nice paper describing how this emissions debt is basically like taking a risky mortgage, and in some ways it's counting on future generations to solve the problems for us. And I think there are profound reasons to be skeptical of using negative emissions in the future to allow continuing positive emissions now. On the other hand, deploying solutions to create negative emissions now to offset positive emissions can be an important part of the solution space. I think in many ways, at least for me, the most promising aspect of where we are with climate concerns the fact that the fundamental narrative about what the solutions look like is different than it was a few years ago. A few years ago, the idea was we could invest in mitigation, decreasing the amount of climate change that occurs. We could invest in adaptation, coping as effectively as we can with a climate change that we don't avoid, or in economic development, and that there was a stark trade-off. What we see now is that trade-off is not nearly as stark, and that in fact many of the best investments in economic development also deliver in terms of mitigation and adaptation. And I'll provide some examples of that, and I think that's the most promising development. And now the challenge we face is moving it from promising to actually delivering on those promises. So energy technologies, the really striking thing is that in most of the world, wind and solar are cheaper than coal. There's no reason to not be deploying them in places that have an established energy infrastructure. When you go to poor countries, a lot of the problem is that their ability to deal with intermittency, with the fact that the wind doesn't always blow and the sun doesn't always shine, is a real challenge. Renewables are, as you know, growing rapidly, but it's still a pretty small slice of the pie. And we face a fundamental challenge that still hasn't been totally resolved of how to provide long-term energy storage when we're talking primarily about electrification. And that's not a critical problem that's slowing down progress in the rich world, but it is a problem that needs to be solved in coming decades. No question that the falling price and the increasing deployment of renewables is the climate story of the last few decades. But it's also important to take a clear-eyed look at where we are in overall deployment of renewables. And if you were reading Oil and Gas Investor magazine, what you would see is a not incorrect picture, which is that hydrocarbons still provide the overwhelming majority of global energy, and wind and solar, even though they're soaring, are still at a relatively low level. A lot of the progress recently has been in electrification of transportation, especially light vehicles. I don't know if any of you had an EV1 back in the 1990s, but the transition of 25 years getting from the EV1 to where we are with electric vehicles today is a good example of how long the technology development pathway takes. But it's also important to recognize that even though the technology is now very sophisticated, market penetration is still quite small, and EVs were only 2.5% of new car sales in 2019. Lots of the kind of far out ideas like the hyperlink as an alternative to electric rail are still just hypotheses. One of the good news story I want to share is how important progress in energy efficiency has been. A picture of Jim Sweeney, who Stanford's energy efficiencies are. And one of the things that Jim always points out is that compared to the trend in 1973, right after the Arab oil embargo, U.S. energy consumption in 2016 was down by 85% relative to what it would have been had the pre-efficiency movement trends continued. And when we talk about the really big success in progress on climate since the 1970s, there's no question it's really been energy efficiency. But when we talk about the solutions, it's important to recognize that they're not just all in the energy space. Many of the emissions, including some of the most difficult to figure out how to deal with ones, come from agriculture. About a quarter of total emissions come from processes related to agriculture. About 14% of global emissions of CO2 still come from deforestation in the tropics. Deforestation has been frustratingly constant over the last several years, especially as we've seen increases in Brazil. And there are also a whole bunch of industrial processes that are really difficult to decarbonize. And we're really at the early days of having the technology available to effectively decarbonize, especially steel production and cement production, which are the two of the biggest users of carbon and emitters of carbon in the industrial sector. Another piece of good news is that we know now that action on climate can be a huge source of employment and economic activity, whether the jobs are in improving the grid and in fighting wildfires or improving the transportation network. And we also are seeing that a lot of the best investments in mitigation and adaptation and development are things like improving the fundamental structures for transportation, communication, public health, emergency response. And we also are seeing that lots of the opportunities in international sustainable development are coming in the renewable energy space. And there are lots of opportunities for poor countries to incorporate renewables into their energy grid, even though the prospects for having them get to zero emissions by 2050 are not the same as they are in the developed world. And we really need some fundamental technological advances. At the same time, we build out the infrastructure in some of these parts of the world. I got a repeat slide there. Apologies for that. We also are seeing, lots and lots of sort of green shoots in the policy space, and whether that comes from the conservative case for action on climate and carbon tax, or whether it comes in jobs, or whether it comes in some of the new financial levers that are being pulled. There are real options, but I think that, from my perspective, the most compelling and the most exciting development is that, we now have pretty good evidence that the net cost of stabilizing warming at in the world of ambitious mitigation, let's say somewhere around 2C, is probably negative, that it's a net benefit economically. So why the heck aren't we doing it? And that's what I want to spend the last few minutes on. I think there are 4.5 reasons that are the holdup. Many of the issues concern the availability of finance and the fact that in a world where we're still subsidizing fossil fuel, it's really hard to liberate the finance that we need in order to accelerate the deployment of the clean energy sources. And we haven't seen the real focus on bringing government finance and private finance into the upfront capital and installation costs that are so important for green energy. And that also includes incentives that can be utilized both within a country and between countries. A lot of the problems we're running into now are clearly, as they always have been, problems of vested interests. And, it's not only in the oil and gas companies, but we see important vested interest pushbacks geographically, so that energy producing states like West Virginia or Wyoming have been famously foot dragging in the climate action space. But also a lot of the powerful vested interests aren't necessarily the ones you would think of as climate solutions unfriendly. For example, a lot of pushback is now coming from investor-owned utilities that are simply apprehensive about changing their business model. I think most people are aware that climate change is an intensely political issue in the United States, pretty much only in the United States, but it still means that, we're in a situation where if the reconciliation infrastructure bill doesn't pass, we may see very little action on climate in the next several years, and potentially not for the next decade. I put a fifth holdup around technology, not because technology is holding us up now, but because we do need to see continued investment in some of the technologies that are going to be critical, especially the technology for long-term energy storage. And it's easy to downplay the importance of this, because in the US we have lots of resources we can utilize to fill in, especially electricity, when it's not available from renewables. But those technologies are mostly fossil-based, and until we have either carbon capture and storage or fundamental solutions that allow energy storage, it will increasingly be a problem, and we need to make sure that it's solved by the time it gets to be a problem. So what I want to advocate is that the big opportunities now are really on near-term benefits that provide this mix of improving mitigation, improving adaptation, and improving economic development at the same time. Grid reliability is a perfect example. When you look at recent disasters, whether it was the Texas cold spell in February or Hurricane Ida, what you saw is that much of the damage, and certainly the loss of life, was a consequence of the grid being unreliable, not of the direct impacts of the cold temperatures or the high winds or the heavy rain. Lots of opportunities for improving infrastructure in ways that improve economic activity. We know that improving transportation and communications are critical for economic development. They're in the bipartisan infrastructure bill. But improving education and social services are also important for unleashing the potential to reduce emissions. And then a final opportunity that we have that we really should be focusing on is disaster risk reduction, and swinging back to the $22 billion disasters in the U.S. We know that we could do a better job with making infrastructure disaster resilient, with early warning, with doing a better job to responding, and with recognizing that we have a lot of communities that are in areas that are simply too risky, and we need to figure out some kind of a way to provide relocation strategies that work for communities and people. So what does that mean to focus on the near-term benefits? I think what we need to do is bring together our work on policy, finance, and equity. And a really important underemphasized aspect of building climate solutions is recognizing that the equity issues cut multiple ways. It's not only that the poor are more susceptible to the impacts of climate change, it's that if we're going to move this issue politically, somehow we have to be more thoughtful and more ambitious in thinking about what happens to the people who lose their jobs in the oil and gas industry, what happens to coal miners, how do you reposition so that we can have a discussion where the finance gets unleashed and the policy can work. The way I think about it is that we've got this big pool of really, really attractive solutions, and we've got this big community of vested interest that's making it difficult to proceed. And they're kind of two strategies of how you might deal with this. I would say that in progressive politics, the idea is to sort of smash down the vested interests, and that, well, I'm agnostic as to whether that could work or not, but I'm pessimistic about whether it will work in the short term. I actually think that we're much more likely to see the kind of rapid progress that we need with an approach that involves collaboration, and that means making deals with the oil and gas companies to bring them into the set of solutions through things like carbon capture and storage, manufacturing, using biomass-based hydrocarbons rather than fossil fuel-based hydrocarbons, and really thinking hard about what's a business model by which the investor-owned utilities can continue to operate and make a profit. Lots of issues there that are really, really challenging, but I don't see a way to get the speed we need without bringing a broad range of interests, including interests who've been the climate criminals in the past, on board. I want to close with a couple comments about what other approaches we might consider. So there really are three. So adaptation, coping with the climate changes that can't be avoided. Can we notch up our commitment to adaptation so that if instead of stabilizing in the world of ambitious mitigation, we end up at something more like 2.5 or 3, could we adapt to that? And what are the limits of adaptation? Could we be more ambitious about removing CO2 from the atmosphere so that even though we're not making the progress we need to make on decreasing the emissions from sources, we counteract that by pulling carbon dioxide out of the atmosphere? And then should we be looking at techniques that are essentially a band-aid that prevent us from seeing the consequences of greenhouse gases by releasing another pollutant in the atmosphere that reflects some of the sunlight? So for adaptation, there are clear opportunities. I think adaptation is one of the most exciting opportunity sets for coming decades. But I think it's important to recognize that there's abundant evidence that we can only adapt so much, and that once we get very much above 2C, our ability to adapt really erodes significantly, and certainly by the kind of business as usual scenarios, there's essentially no possibility of effective adaptation. Carbon removal, some of the best opportunities are doing a better job of protecting forests and restoring forests. There are ways that we can increase the fertility of soils with better soil management. There are some techniques that are under development now to capture carbon dioxide in a way that allows us to make it into rocks. I'd say those haven't proven out at scale, but they're looking really, really interesting. And then there are some industrial ways for capturing CO2. Lots of opportunities for natural climate solutions, and I'll show you how much I think they can accomplish in the next slide. They can certainly accomplish a lot, but not be the whole solution. Industrial CO2 removal can work at scale, but at this point it is relatively expensive. And if it weren't for the 45Q tax credit, which is $50 a ton for CO2 storage, we wouldn't be seeing very much of it. And it also is a far from mature technologically. With natural climate solutions, how much can we achieve? There are a whole bunch of studies have been published that report on that. And they range from the idea that we could use natural climate solutions to remove more than 1,000 billion tons of CO2 from the atmosphere to well less than 100. The amount the IPCC says we need to remove to stabilize at 1.5 C is what's shown in the orange. And you can see that most of the estimates are that the potential for storage is well below reaching into that orange band. And a reasonable estimate is that the potential of natural climate solutions might be on the order of, maybe 200 to 300 billion tons of CO2, a really important part of the solution set, but far from transforming the picture. And as climate change proceeds, we're seeing more and more indication that the ecosystems that we're hoping will provide more carbon storage in the future are in fact providing less. That's from things like wildfire or other impacts of climate changes. And it's important that we not count too much on the idea that natural climate solutions can deliver the level of permanence that we really need for a durable solution. Solar geoengineering, incredibly controversial, incredibly poorly understood, many ethical and moral questions. But we also don't know what the risks are. We don't know what the social dynamics likely to be and whether it's feasible at all. And I feel like it's really hard to be responsible about looking at the whole set of possible solutions without a research program on solar geoengineering. And that's what I advocated in a recent report of the National Academies of Science, Engineering, and Medicine. So as we approach COP26, it's important to remember that stabilizing at less than or equal to 1.5, really unlikely through decarbonization alone. I think stabilizing even less than 2C is unlikely through decarbonization alone, particularly when you look at the international perspectives and the legitimate aspirations for economic growth in the developing world. I think the key to near-term progress is the focus on solving near-term problems that deliver a win in terms of economic development, in terms of mitigation, and in terms of adaptation. But we do need to recognize that this nexus of policy, finance, and vested interests is a really important one that we need to be thinking hard about and can't really ignore. We also need to dramatically increase the commitments to adaptation, carbon removal, and take a serious look at solar geoengineering so that we have at least a little bit of a backup plan. We're now 6 years past the Paris Climate Agreement, And the Paris Climate Agreement really established two incredibly fundamental features of the map of the future. First, it established a global agreement on what's fair. You may argue with some aspects of that, but every country agreed that the agreement outlines a fair approach to tackling climate. And it also laid the foundation for a predictable future, incredibly important for unleashing investments, especially from the private sector. But I think the really important next challenge, and the one that I hope gets addressed in Glasgow, is that the agreement hasn't really put the attention that it should on what's climate justice mean, and how do we make climate justice as central to the discussion about climate change as we make decarbonization. So thanks very much. I would love to take any questions.
Okay, thank you very much, Chris. I think there'll be a lot of questions, and what you should do is raise your hand and
hang on. I got a couple things to go on that. So first of all, I do have, as Greg said, yes, please raise your hand. I already do have some questions, though, that came out of the chat. And the rule is going to be, you can ask one question, and then please join the end of the line to ask a second question. So I do have several questions already up here, and hang on while I get to the top. Okay, the first question came from Tom Kabat. Is that right, Tom? You talked about a study or two that looked at the future emissions. So if you want to go ahead and phrase that question for Chris.
Sure. Yes, thank you. So Dr. Field, I've seen a couple of studies that have looked at the future emissions from all of our existing fossil-fired equipment, the trucks, cars, furnaces, refineries, all that stuff we're already running. And they found that by running that equipment to the end of its useful life, the emissions from that is enough with our other activities to push us to the 2 degrees sea level rise. And when I hear about that, it sounds like then there's no more room to keep replacing that equipment with fossil-fired devices if we value not going much over the 2 degree rise level. And so I was curious if you see that the same way, and if then it makes sense that we, especially those of us who are wealthy, pivot away from using fossil devices to replace our burning out things.
That's a really good question, and I agree with the conclusion that the emissions that are intrinsic to the existing technology certainly push us over 1.5 and close to 2. There's a question about how much we want to pay for early retirement of things like vehicles and power plants that would allow us to switch to non-emitting options. And of course, there is a real cost involved in the early retirement. And there's some things that clearly we shouldn't be continuing to build. There's absolutely no motivation for building additional coal-fired power plants. But there is a motivation for building some kinds of fossil technology, and for things like developing a transportation network in parts of Africa that don't have transportation now. We really don't have the technological capability to do that 100% on renewables. So I think we need to recognize that the world is a complicated, variable space from place to place, and there are lots of opportunities for rapid decarbonization, especially in the rich world. Although if we're going to stick in this mode of making the decarbonization as economically efficient as possible, we want to be really careful about early retirement. I would say that we want to focus on the most grossly emitting technologies, like coal-fired power plants, and recognize that for things like over-the-road trucks, for which we don't really have a good alternative right now, we probably are going to be looking at some decades of continued emissions.
All right. So the next question in our chat came from Cheryl Wyden. She's asking about, could you comment on the varying positions that different schools of Stanford take on climate change, on what needs to happen? And Cheryl, did I miss it? An important piece?
Well, thank you very much, and thank you, Dr. Fields. My husband and I have been going to the Stanford Energy Summits for years, and we noticed a change. And now there's a new school at Stanford, and we're getting totally confused about what Stanford is doing with climate, because we have Dr. Jacobson saying it can all be solved, and you saying, and I think the Woods Institute saying it's a crisis, and then the Precourt Institute is bringing all these speakers from the oil and gas industry saying, we're going to have oil and gas forever. And I am totally confused as to what Stanford's position is. And it's very concerning because Stanford could speak with a credible voice, but from an outside observer, it's being diluted. So can you explain what Stanford is doing and what the position really is?
Well, I can tell you that universities are incredibly bad at speaking with a single voice on anything. And, you know, universities in the US and around the world are pretty much founded on the idea of free expression and academic freedom. And I think that if I were to characterize where the diversity of opinions on what climate change solutions look like, as far as I know, all my colleagues recognize that climate change is a real crisis, demands rapid action. Some colleagues, like Mark Jacobson, are very optimistic about the current status of technologies. You know, Mark makes some pretty heroic assumptions about the extent to which we can utilize things like hydropower resources that other people have other uses in mind for. And he also makes some very strong assumptions about the level of political commitment that might be mobilized. I would say in general, my colleagues in the Precourt Institute on the energy side, even people whose research is based on fossil fuels, recognize it's an important, a critical problem, and that we need to make rapid progress. And I think that, you know, for them, at least in their research, is focused more on the kinds of improvements we can get sort of along the pathway to decarbonization. So without putting words in their mouth, things like being able to more rapidly transition from coal to natural gas as a bridge is an important topic. And increasing the efficiency of combustion in things like natural gas turbines is an important research topic. And I think that in the right time frame, I would agree with those things as well. I don't think there's anyone who feels that this is anything other than the defining challenge of our era. And I don't think there's anyone who feels that that there's a solution that in any way is different than zero net emissions by the latter decades of the 21st century. Going beyond Stanford, if I look at the energy projections from, for example, Shell or Chevron, they also show zero emissions by or to the 2080s, but they show that with a mix of continuing emissions from fossil sources and CO2 removal from natural climate solutions and direct air capture. And as I described, we don't really know how much progress we can make on the CO2 removal technologies, and we certainly don't want to put ourselves in a position where we are expecting emissions now to be counterbalanced decades in the future by CO2 removal.
All right, I'm going to mix in now some other raised hands. Marshall, are you there?
I am. Thank you. Chris, that was really a great informative talk. Covered a lot. I was really pleased to see that you covered policy and somewhat politics in addition to science. You're a scientist, as I am. But I want to ask a question combining science and politics. It's somewhat of a swerve about the discussion so far. I'd like to know if you think that the very rich and major impact industries have really understood the severe dangers of global warming on food, water, sea level rise, national security, and I emphasize national security, for more than a decade? And if so, does their recognition of these threats explain their attempt to install authoritarian governments worldwide to protect their interests?
Wait, you're definitely beyond my area of expertise with that question. Let me just say a couple things about what I think big companies knew and what the scientific community knew at various points in time. You know, I showed you that in 1990, the IPCC had a good projection of where climate was headed, but they had very low confidence in it at that point, and certainly were not anywhere close to saying, well, they weren't close to saying even that the climate has warmed historically, and they certainly weren't close to saying that humans have caused it. And I think it's pretty inconceivable that at that point, oil and gas companies knew a lot more than the scientific community. So I don't think that it's a situation where the oil and gas companies were had information that they were hiding that was fundamentally different than what the scientific community had. There have been points more recently where that was the case. And I think that, you know, in general, my impression is that big companies around the world, whether it's, you know, Amazon or Exxon, recognize the impacts of climate change. I think the oil and gas companies have mostly been involved in a sort of a finance shuffle, trying to adjust near-term competitive positions and being less concerned about the future than was prudent or responsible. And I think that the big companies like Amazon I think they're trying to be responsible, but in a very narrow and shallow way. And as you probably know, lots of big companies have really invested in carbon offsets, using natural climate solutions to offset their emissions. And I think that one of the things that has come of that is because a lot of these offsets are very low quality, we haven't seen the level of emissions reductions that the companies are actually claiming.
All right. I want to try and get in a couple more questions, but we are running out of time. The next one from our chat is from Richard Selwalk, and you were asking about economic growth, and maybe if you want to paraphrase that, see if we can. But it's got to be short because
right.
we're so we can get some more in. Thank you.
So thanks a lot for your presentation, which we all found really helpful. What seems to, in a couple of your slides, you seem to give economic growth sort of given status in the future. And whether or not it's desirable, it seems like we're facing lower return on our investments, energy returns on our investments. Simply to maintain our lifestyle, we need to keep using a larger percentage of our available resources as EROI drops certainly for renewables, and even the existing fossil fuel energy sources have declining EROIs. So a straightforward outcome of that is that economic growth can't rise. At best, we maybe hope for steady growth, but it seems like a declining growth is likely as we have to shift more and more of our energy resources into constructing more renewable energy infrastructure or whatever other possible solution or response there is to climate change. And I know it's not welcome, but doesn't that seem like a sort of a economic reality that we really need to face? Thanks.
So I think the aspect of economic development that's really important to keep an eye on is economic development in the world's poor countries. And I think that there is no ethical or political justification for preventing the kind of economic development that would raise the poorest half of the world's population out of poverty. And, you know, we could have a really good discussion about whether that means that in the rich world, we have stable economic activity or a little bit declining or a little bit rising. And I think all those are fundamentally compatible with where we need to get, but there does need to be economic development in the poor half.
All right, next question is coming from Elsa, and if we can make it short because we're out of time.
Thanks so much. And Chris, thanks for such a stunning presentation, and we love your slides. They were too small for us to read all that gorgeous thinking. So if we could have them, they'd be great. We were so glad, or at least some of us were so glad to see your recommendation to have combinations of solutions that were technology as well as politics, as well as regular humans' behavior change. Do you see value in continuing to try raising action-oriented awareness among regular people to both change behavior and the types of energy they use? And I think of a couple of things. Modi's request at the Paris conference to have the developed world transfer technology to the poorer companies, or at least in your framing, the technologies that are fairly developed now. And do you like or laugh at Congress's bill to put a fee on carbon as it comes out of the ground or into the country to help stimulate faster awareness of the need for behavior change, as well as the transfer to renewables?
Yeah, so I know we're out of time. I'll give very brief answers. In terms of carbon price, a carbon tax, it'd be wonderful. The economists all say that's the most efficient way to do it. But there are lots of ways to pull policy levers to decrease emissions. And I don't think we should be fixated on any one. In fact, I think one of the wonderful things we're seeing now is cities and states in the US and countries around the world are trying different policy levers. And we have a good laboratory for seeing what works and what doesn't. In terms of the role of individual action, I think it's important for people to continue to think about what they can do through lifestyle, vote style, invest style, activism style. I hope the overall message that I communicated is that I think progress depends on a amplifying relationship among all those things, and that we need to be cognizant of the risk that if we put all our effort in one area, we're likely not to see as much progress as if we recognize that we need to work the politics, we need to work the finance, we need to work the public activism, and we need to have those stimulate each other.
Susie McKee, we've got time for a quick question.
Okay, I hope it's quick. So I've been recently seeing information on regenerative agriculture, which seems to be, and you know, things like the fertilizer industry are worth billions of dollars, and they would be undercut by real regenerative agriculture. And I just wondered if you ever considered that in what you've been looking at.
Yeah, I spoke briefly about the potential for using agricultural soils to store additional carbon. You know, if you look at agriculture over the last little more than half century, it's really been a remarkable story of success. It's been driven mainly by the green revolution approach of plant breeding to allow more fertilizer to be used, putting on more fertilizer, mechanizing agriculture, and we've seen yields increase by 1 to 2% per year over more than 60 years. It's truly an amazing story of success, and there are lots of reasons to think that we're running out of that success now, and that deploying things like regenerative agriculture can play an extremely important role in allowing us to maintain increases in ag yields. But the main message I want to leave people with is that we're going to have to be deploying a wide range of agriculture strategies to sustain the level of progress that we have seen over past decades. And there's nothing I've seen in the scientific literature that says that we're likely to see a step change in the rate of improvement of agricultural yields. We do need to be deploying regenerative techniques, and we need to be deploying everything else at the same time.
Well, we need to do them for many other reasons. I mean, places that had it, when fire comes, are less likely to be burned. I mean, there's so many reasons that it seems like it's a really important element in this. And I know it'll be fought because of things like fertilizer, which is not the same as having genuine fertilizer from compost or other elements in the soil itself. So I just want to emphasize that, because I think it's not given as enough credit. It's not just sequestration, not just carbon. I can't think of the word now. Sequestration, but sequestration, right? It's not just that, but there's many other things that it produces that are valuable. Anyway, I know we're out of time, so.
Okay, and I'm going to let Greg ask the last question, and then we're going to wrap up.
Okay, I had two questions, but I'll have to pick one. I'll pick one. Yes. If you want to talk about agriculture and you look at the statistics, how about not eating red meat anymore?
Yeah, that would be a powerful thing to do. About a quarter of greenhouse gas emissions come from agriculture. The emissions per calorie from eating beef are more than 10 times what they are from eating plants, and they're more than 5 times what they are from eating chicken or pork. And if we did transition away from animal agriculture, it would be an important dent. I hope I leave everybody with the message that we've got to tackle everything. We've got to tackle we make electricity, we've got to tackle transportation, we've got to tackle the way buildings work, we've got to tackle lots of things related to land use and agriculture. And we don't want to overlook any of the places where we can make real progress in decreasing emissions.
Meat is a vested interest.
Oh, sure. I mean, as are all those things.
And I know we didn't get to everybody's questions, and I would love to just keep going, but we're going to end. But I want to end on a good note, because if you guys aren't all aware, San Mateo County is trying to do something, and they're trying to do collaborative work. We have a group called One Shoreline, and they are our Sea Level Rise organization. They're part of the county. And some of the things that they're working on right now, you talked about sustainable development. So they're doing a project up in South City, and it's on the bay, and it's flood territory, it's landfill territory. But what they're doing is they're working with the developer there to develop so that they're not only looking at the 100-year flood, they're looking at sea level rise plus another extra 4 feet, 10 feet, something like that. So what they're doing is working from ground zero and saying, okay, you want to build? Okay, then we got to build to meet these new requirements coming in, and that the cities are looking at their planning departments to help work on this. But they're seeing a success in South San Francisco. Brisbane is also looking at this because they've got a big development project there along the bay. And they're looking at these collaborations with, okay, what is Caltrans going to do at 101? what is the city going to allow in their planning, and working on these as collaborative projects. So if you're going to build, and we need to build, then let's build to make sure that we meet the coming criteria, that we're going to meet something that in 20 years won't be flooded. So that there are some bright pictures around here. And I think that's just one example. And Chris, you talked about these overlapping circles, and it's the collaboration that's required to be able to do this. And it's the public, private, government sides, everyone working towards that common goal. And I think that's just the way we need to be looking forward. And it's all of these pieces. And Chris, I just want to thank you. It's been a tremendous evening, and really appreciate you coming and talking to us.
Thank you very much. And if you send me the questions in the chat, I could send answers back.
Oh, perfect. We can get
How
that.
How optimistic or hopeful are you?
That's a good ending question.
So I'm very optimistic that we can solve this problem. I have medium optimism that we will solve it in the world of ambitious mitigation. And I think that all of us have a deep responsibility to get us as close to that as we can. Thank you, everyone, for a wonderful series of questions.
Thank you, Chris.
Thank you.
Thank you.
All right. Well, our next up on our agenda.
Did we ask Chris if we could have access to his slides? I didn't ask that.
Yes, Elsa did.
Oh, good.
And we can follow up on that.
Good. Okay. Sorry about that.
Yes. So Diana, if afterwards we can get the chat log and we can send those last questions to Chris.
I have I took pictures of all the slides. I may help you get some of that. And I do want to point out that in Foster City, the levee has been built probably 15 feet high in concrete because of the sea rise.
Right. And that was a piece that is part of this One Shoreline collaboration, is where the edge of Foster City meets the next city. They have to be working together in order to make sure that we're not leaving gaps. And another example there